Another method we have for solving a system of equations is to use the addition method, and that's what we're going to practice here. So the first equation that we're going to look at to solve by using the addition method looks like this one right here. What the idea is behind the addition method is, we're still looking at these variables right here. I want to try to turn, let's say I want to get one set of variables to have the same coefficient, opposite signs, so that when I add the two equations together, I actually eliminate the variable. And that's the idea behind the addition method. So if I look at these four variables here, and I'm trying to decide, because I get the choice, do I want to get rid of the x's or do I want to try to get rid of the y's? Well, I'm going to tell you that I'm going to choose to get rid of the x's, and this is why. Because if I look at my two variables here, or the coefficients I mean, in front of my variable, and I'm trying to figure out what is the least common denominator between 1 and 4. So the least common denominator between 1 and 4 is really 4. So in other words, if I multiply this top equation by 4, that gives me a 4 here, and if I add that to -4, I will eliminate the variable x, and that's the goal here. So what we're going to do down here below is I'm going to multiply the first equation, everything in it, by 4. I have 4x plus 2 times 4, which would be 8y, is equal to 8. And I rewrite the second equation, -4x plus 3y is equal to 25. Now it's called the addition method because I am going to add the two equations together now. And when I do, that eliminates the x's, and it gives me 11y is equal to 8 plus 25, which is 33. And that's pretty easy now. I just divide everything by by 11, and I find out y is equal to 3. And now that we know what y is, we go back and we substitute it in, and I am going to substitute it into this equation here. I'm going to go back to the original equation before I ever manipulated it with this 4. So I'm going to plug it back into that equation, x plus 2y equals 2, and solve for x now. So I'm substituting back in a sense. So I have x plus 2 times 3 equals 2. So x plus 6 equals 2. Subtract 6 to the right, and I get x is equal to a -4. So the solution to this systems of equation is an ordered pair represented by -4, 3. So there's one solution to that one. Let's try this method again using this system over here. So if I'm using the addition method, I'm going to try to figure out a variable that I want to eliminate, and I'm going to add the two equations together to eliminate that variable. So I'm going to choose to do the y's this time. I kind of go for, if I have a variable with only a 1, then that's the one that I choose to eliminate, because I only have to multiply one equation to make these two numbers the same. So again, the least common denominator between a -3 and a +1 would be 3. So I'm going to multiply the second equation, the entire second equation, by 3. So let's rewrite the first equation down here. 9x minus 3y is equal to 12. And it's the second equation that I'm multiplying by 3. So 3 times a -3x is a -9x plus 3y is -12. Now I'm going to add this together. 9x minus 9x, well, that's just 0. -3y plus 3y, that's 0. But I'm going to put the 0 here on the right or the left anyway. And then when I add 12 and -12, that is 0. Okay, so we're going back to the idea that I have 3 possible solutions for a systems of equation. When you get something that looks like this, you want to ask yourself, does 0 equal 0? Yes, that is a true statement. If it is a true statement, then we get infinite solutions. In other words, the two equations that you see here in your system are actually the same equation. And you could see that if I were to divide this top equation up here by 3, 9 divided by 3 is I have to divide everything up here by negative 3. So 9 divided by a negative 3 is a negative 3. Negative 3 divided by a negative 3 is a positive 1. And 12 divided by a negative 3 is a negative 4. So in other words, the only difference between these is by a factor of negative 3. So they are the exact same equation lying on top of each other. Let's practice this one more time using this system right here. 2x is equal to 3y plus 4. 4x is equal to 3 minus 5y. Now I put this one on here for us to practice because up until now, when we have been using the addition method, all of my x's and y's have been on the left and the numbers have been on the right in both of these scenarios. Well, that's not the case that we have here. And I still want to be able to use the addition method. So I'm going to rewrite this so that all of the variables are on the left and the numbers are on the right. So this is going to look like 2x, and I'm going to subtract 3y to the left is equal to 4. And here I have 4x plus 5y is equal to 3. So I just moved my y's over to the left. This is the system now that I want to try to identify and see how I can add it together. We get to choose, we get the choice, do I want to get rid of the x's or the y's? If you look at the coefficients here, I don't have any of them with a coefficient of 1, so what I've been doing previously doesn't work this time. Instead, I want to think about least common denominators. If I want to eliminate the x's, the least common denominator between a 2 and a 4 is just a 4, right? Well, what would I have to multiply by? What would I have to multiply this equation by to get a 4? I would have to multiply this equation by 2 so that I have a 4 here and a 4 here. When I add those together, they need to be opposite signs. So I don't only need to multiply by 2, but I need to multiply by a negative 2. Because that would give me negative 4x plus 4x, and it would eliminate the x's. Now, I'm going to take a side note here, and I'm going to say, what if I had chosen to get rid of the y's? What would be the least common denominator between a 3 and a 5? The least common denominator, if I wanted to get rid of the y's, would be 15. So I would have to multiply this equation by 5, because that would give me 5 times 3 or 15. And this equation down here by 3, because that would give me 5 times 3 or 15. Notice that if I chose to get rid of the y's, I have to now multiply both equations by some different, by factors to make these two coefficients add to give me 0. And that's why in this particular case I chose to get rid of the x's. So let me get rid of this so it's not confusing later on. Going back to the top equation, I'm going to multiply this top equation by negative 2. So that gives me negative 4x plus 6y is equal to negative 8. And the second equation is 4x plus 5y is equal to 3. Those are the equations I'm going to add together. You can see the x's are eliminated and the y's become 11y is equal to negative 5. So I'm going to divide both sides by y, and I get negative 5/11. Now, it's okay if you get a fraction. Don't forget that fractions exist in the real world, and not all of our answers are pretty answers. So this is okay. We're just going to take this y and we're going to substitute it back into one of the original equations to be able to solve for x. So I'm going to just choose the top equation because it's the first one I see, and I say 2x is equal to 3 times negative 5/11 plus 4. And I have 2x is equal to, when I multiply 3 times negative 5/11, I get negative 15/11 plus 4. Because remember, when you multiply a whole number times a fraction, that's like multiplying 3 over 1. And you multiply numerator to numerator, denominator to denominator. So I have 2x is equal to negative 15/11 plus 4. If I were you, I would take negative 15/11 plus 4 and add those two numbers together on my graphing calculator pretty quick, and make sure that you you keep it as a fraction, and that's going to give me 29/11. And then when I divide both sides by 2, that's the same thing as multiplying both sides by 1/2, I end up with 29/22. So just in case you don't know how to do that on your graphing calculator, if I was to say negative 15/11, and I'm going to add that to 4, and then I do math, frac, enter, enter, it returns for me the value 29/11, which I am now going to divide by 2, and I still want my answer in fraction form, and I get 29/22. So you can do that part in your calculator. Don't be scared if you get fractions, and understand that the solution we now have for this is 29/22 for the x value and negative 5/11 for the y value. This is the ordered pair that represents the solution to this system of equation. So this is how we can solve a set of system of equations using the addition method.